have a lot of different types of wheels in VEX. You have something like this, which the shaft just goes through the hole here, nothing fancy. You have other types of wheels similar to this. You have larger traction type wheels, same kind of thing, same basic concept. And then what's interesting in VEX is you have these things called Omni wheels, and they rotate like a normal wheel, like a standard wheel, but they have little wheels, little rollers, that allow it to move sideways. So the interesting thing about using these is that you can design a robot to go forward and backwards, but depending on how you gear it or how you design the drive, you can also get the robot to turn more efficiently, or even in what's called an X-strafe configuration, it can move forwards and backwards and sideways, or some combination of that. And then you have this kind of thing, which is called a mecanum wheel, and these are kind of crazy. They can allow the robot to also go forwards and backwards, rolling this way, but then with the code you can do something really strange and make the robot go side to side, or also some combination. These are not very efficient as far as energy goes. They're kind of expensive, so for a beginner I would stray away from using these. Just to let you know, there are two main types of shafts in VEX. They're both square shafts. The type of shaft we're going to be using in this video is sort of a standard shaft. You can see it's a little smaller than these high-strength shafts. So just so you know, the high-strength shafts, they come with their own size bearings. They look like this. Their own size shaft collars, and also their own size spacers. We're not really going to talk about these in this video. We're going to stick to the standard size shafts, which are, as you can see, they're much smaller, but they fit directly into these kind of holes in the wheels. For the standard size shafts, you have two basic types of bearings. I think of this as sort of the normal bearing, or a straight bearing. It has 3 holes in it. There's also another kind called a pillow block bearing. Very little different. For the normal bearing, you want to make sure that when you mount them on a piece of C-channel, I don't know if I can see it very clearly in this video, but there's little tabs right here, little protuberances, and you have to get those mounted into these holes. So you have to sort of put it in to where you want it, kind of wiggle it around and make sure it's going to stick there. Those fit into those square holes and help hold it on there. So before you screw it down, kind of wiggle it, make sure it's really fitting in there. So when you mount a bearing, you'll want to use an 832 screw. Don't use the 632 screws. They'll be too loose, I think. It doesn't matter. Well, it depends on how you plan out your mount, but it doesn't fundamentally matter which side the screw goes into. Okay. The other thing to keep in mind is just put as long a screw in here as you really need. I mean, you want to find a screw that's matched, just big enough, you know, that it has just enough thread sticking out that you can put your nut on it, and the nut's fully engaged, not partially engaged, and so you're not really wasting any of the space in your mount. I mean, if it sticks out a little bit, it's no big deal, but it really depends on, you know, what your configuration is for your motor and how much room you want to have, or if you want to put the wheel on this side or what. Okay, so there are two main ways to mount a bearing like this. You can have the screws on the outside so that the shaft goes through the center hole and rotates in there like that. Or you can put the screws in the 2 adjacent holes and leave the side hole open for the shaft to go that way. A lot of that depends on how you configure your motors. Of course, depending on what you're doing, you could use a Kep's nut or Nylock here for this sort of thing. As usual, I would suggest using a Nylock for your final design. For a prototype or an experiment, the Kep's nuts are fine too. The bearings also fit the holes of the 5-hole and 3-hole C-channel. So just so you know, the way the motor works is these holes here are used for screwing the motor in and mounting it. That hole there is square, and that's where the shaft will fit into. One of the common mistakes that kids make is they only use one bearing. They'll mount their motor, they'll have a shaft, and then they only use a bearing over here, or sometimes over here. You don't want to do that. You always want to use two bearings. In this case, you can see the kids put screws on each side of this bearing, but on the other side they had screws adjacent. The holes line up. It doesn't really matter how you do this for most applications. All that matters is that the hole for the shaft is in a nice straight line perpendicular to what the bearings are mounted to. You do not want something going in crooked, either this way or whatever. Okay, so these standard size shafts come in about 12 inches long, but you can also get them pre-cut from Vex in different sizes also, like about 3 inches or 4 inches or something like that. When selecting a shaft, it's very important to make sure that it's straight. If you get a little piece of shaft, you don't know where it came from or whatever, certainly, well, one thing you can do is you can just use a straight edge and just hold it up there and see, how's it look. But if you don't have a ruler, straight edge, or something like that you trust, you can get another piece of shaft, and you just take the shaft you're interested in, put it up against preferably a new shaft, and then just kind of rotate it on there and see, is this thing bent? What's going on? The chances you're going to have two shafts bent the same exact way is not very high, especially if you're rotating them, or rotating the one. You'll see sometimes that there's a gap here where the whole thing just bends completely away. You don't want to use it if it's bent. Or at least you don't want to use it for wheels. The other thing you want to make sure of is that the shaft doesn't have any burrs on it. And by that I mean like little places where it's been dented or whatever. A good way to do that is first just sort of feel along it, and then especially at the ends, because the end is what has to fit into the hole on the wheel. Make sure that there are no little points that stick up, and the best way to do that, I think, is to take your thumbnail, your fingernail, and just rub it on there, and if it slides right off, it's fine. If it seems to hook on something, then you know you've got a burr. You can also have burrs along the body of it, and you don't want those to be giving you problems either. So if you have a burr, there are a number of ways to get rid of it. One nice way to get rid of a burr on the end is to use a metal file. Remember that a file cuts only when you're pushing away. So on the edges, or on the ends, you want to just push away and sort of rotate the shaft in your other hand while you do that. A file really doesn't cut going the other way, so you don't want to saw it back and forth like that. And then you want to sort of roll it a little bit like that, so you kind of round off the end of this shaft when you're finished. So just sort of roll it and push it away. Another thing you can do is use some fine sandpaper, preferably after you're done filing, and just kind of also again try to round that off. When it comes to types of sandpaper, a fine sandpaper would be something like a 400. This stuff here is a 320, very fine. That's the sort of thing you want to finish up with. That gives you a nice smooth rounded end on your shaft, which when it comes to getting this into that tiny little hole will make your life a lot easier. Because it's so important to make sure your shafts are straight, you want to make sure that they stay straight. So avoid leaving these laying around in a place where somebody might put pressure on them. Don't leave them laying around on the floor where someone can step on them. Don't put them, leave them on things like that and somebody puts their books on there. These things can bend, and once they bend, they're not much use. So in my opinion, one of the fastest and easiest ways to cut a shaft is to use bolt cutters. You just put those in there and clamp it down a little bit on the point where you want it to cut. You always want to use safety glasses when you're using something like this. The tension just builds up into this thing until it snaps. And if that's flying through the air and hits one of your teammates in the eye or something, or even this can do some damage to them. So make sure you're wearing safety glasses. Make sure you're wearing safety glasses. Make sure you're wearing safety glasses. When it comes to inserting the shaft, you'll notice some of the wheels come with the tiny hole. Just built into the wheel. Like these Omni wheels have a same size hole as the small shaft, and so does this one. Some of them don't come that way. They'll come with a larger hole, which actually fits the larger shaft. But it's sometimes a lot more convenient to use the smaller shaft for the wheelbase, at least right now, until VEX comes out with different parts. So you'll see people use these metal inserts. They look like this. That's what these little things are. And they fit into these holes and basically adapt the large hole to the smaller shaft size. You'll want to put one of these on each side of the wheel when you have this kind of wheel. There are also plastic inserts. These, though, have a round hole in the center, not a square one. So they're not, you can stick them inside the hole of the wheel, but that's only if you want the wheel to be freewheeling and not driven by a motor. So it's not useful for what we're doing right now. This one just squeezes on there, and it just holds on by friction. This is probably perfectly fine if you're doing a prototype. I don't think I would trust this in a competition. I think it's too likely for it to pop off. There are these kind, which are plastic, and they have a metal screw. You basically tighten these up, and it just clamps down on the shaft. Probably my favorite is this kind. It's a metal one. It's got a set screw that goes right down to the shaft. If you're going to use this, make sure you line up the set screw with the flat face of your shaft. Don't try to screw down onto the corner of your shaft. One of the more common mistakes I see beginners make is they put the shaft collar in the wrong place. Now, the motor has this hole, this square hole that the shaft will go into. Once the shaft is in there, well, the shaft can't go all the way through the motor, so the motor prevents the shaft from going that way, but it doesn't do anything to keep it from going this way. So you'll see kids mount the motor on this side, so the shaft is going into it, and then they put their shaft collar over here. They think, oh, I've got a shaft collar on here, I'm good to go. Problem is, a shaft collar is also going to prevent the shaft from going that way. So the motor stops the shaft from going that way, so would the shaft collar. The shaft now has two ways to keep it from going that way. That doesn't help a whole lot, because eventually this shaft can just pull straight out. Now I'm going to mount the motor. As you know, you have a square hole here. That's where the actual drive is. These two holes are for mounting the motor. In this particular case, I've got two screws holding on this bearing on the side here. The bearing hole is right there. So the motor screws have to go in on this side. So to mount the motor, remember there are a different type of screw that is used for that. These are the 632 screws. They're sort of a brassy color. From VEX, I think they normally come in like two lengths. These motors produce a lot of vibration, so the short ones are fine, I think, if you're experimenting, but I would go with the longer ones for the competition bot. Okay, in this particular case, I need to do something a little odd because of the way the bearings were mounted. It's not a big deal. I just have to insert the little Allen wrench on this side, put the screw on there like that, put the motor in its holes, And then get the first screw in there. You'll feel a little bit of resistance maybe as it encounters as the screw encounters that epoxy, the red stuff that's on there to sort of hold it in place. That's natural. Get that first screw screwed in all the way, but not too tight. Don't tighten it. Don't give it its final tightening yet. So you can leave that a little bit loose. Do the same thing with the next screw. You might have to find a different hole and sometimes to get these. It's okay to kind of come in at a little bit of an angle if you can't get directly to it. So same kind of deal. Get the screw in there. Doing the final tightening this way with the short end. Probably one of the simplest, fastest, easiest ways to mount your wheel is on the opposite side of where the motor is. Figure out the number of spacers you might need that will push up against the bearing and position your wheel pretty much in the center so it won't rub on anything. And then on the other side, you're going to want to mount the shaft collar right up against the wheel. And the reason for this is when the shaft is inside here, the motor will act as a stop, so the shaft can't drift going that way. So the shaft is going to bump up against the motor, inside the motor, and not move in this direction to the right. But there's nothing to stop the shaft from going this way unless you have the wheel centered here, shaft collar there, and then with the spacer and everything sandwiched like that, there's no way that the wheel can drift or that the shaft can go that way. So I think the easiest way to do that, to put this together, is some kind of spacer, wheel, and then shaft collar, and that allows you to have very easy access to the shaft collar once it's on there. So basically, after you have the motor mounted, you put your shaft in, put your spacer that you've selected, stick it through the wheel. You'll see a little bit of the shaft come out. You can get your fancy pliers, or if you've got nimble fingers, you can get them in there. Continue to shove the shaft all the way through. Make sure that the shaft collar, by the way, that the set screw on the shaft collar is loose. Shove that all the way through, and then you might have to kind of wiggle and rotate to make sure that the square shaft is actually lined up with the square hole. For me, I have to use a piece of rubber because I just can't get a good grip on that. And then that clicks in there. After you get the shaft into the motor, make sure the shaft stays in the motor, push your wheel over to where you want it to be. Well, it should be butted up against the spacer. Get your shaft collar in position right up against the wheel. Make sure that the set screw of the shaft collar is aiming right into the flat face of the shaft, and then tighten up the set screw. And once you have that tightened, now you'll hear it buzzing as you rotate it. That buzzing sound is from the internal gears of the motor. If you use the other type of shaft collar, this kind in here, just be careful that when this rotates, that this nut and everything isn't going to chip against any of the C-channel or against the nuts or screws or anything that you have holding the bearing in here. So there's a number of configurations that you can use. Just kind of keep in mind how that shaft's going to move and what's going to stop it from moving. As long as you do that, you can come up with different configurations for where you want to put your spacers and shaft collars. One thing you want to remember about the 393 motors, when they come out of the box new, they are geared for torque. Inside this casing are some tiny gears. It's generally called torque mode, the way they come. You can open up the back of this and change the gears so that the motors run a little faster. I think about 50% faster, and that would be considered a speed mode. But when you go to speed mode, you lose some of the push ability, you lose some of the torque ability of the motor. There is also a turbo set of gears that makes it go even faster, but then again, you'll lose even more of your push power. For a beginner, I would suggest just using the motors in the torque mode, the way they come new out of the box. That makes the robot have more push ability. It also keeps it from going too quickly, so that it gives you a chance to learn how to drive this thing and not wreck it. So I think just the way the motors come out of the box is the best when you first start out. Later on, you can learn to change the gears inside here and up the speed if you want to. Okay, so now that you know how to mount one motor and one wheel, to build a very simple robot, the only thing you would need is to mount at least one more of these, say over here. That would give you 2 driven motors, which would allow you to steer. The other 2 wheels could be just passive, just ones that roll around. This is a very basic chassis. It's built from 2 pieces of 35-hole C channel here, same here, a piece of 35-hole C channel here and here, and an angle piece here. Actually, I wouldn't even need this angle piece. You could probably build a chassis like this with just the 6 pieces of C channel, and you don't even have to cut them. That's what's very nice about the size of these. You could build a simple chassis without having to cut any of this metal, and it would still be legal within the 18-inch limit. But of course, if you wanted more power, you could mount one of these wheels and motors on each corner. My own feeling is that if you stick to something simple like this to start with, you can learn very rapidly. So keep it simple at the beginning, and you can rapidly work your way up to something more complex. One of the biggest mistakes kids make is they try to do, the ultimate robot the first go around. If you start with a fundamental chassis with 2-motor drive or 4-motor drive, you can rapidly go from there. That's it for now. I hope that helps.